All right, so this is the second lesson with mean absolute deviation. And your learning objective, we will calculate and interpret the mean absolute deviation of a data set. You have two standards, SID, which is statistics, and then you have another standard, NQ, which is numbers and quantity. The mean absolute deviation is a complicated name, but all it really means is that we're summarizing the variability from the mean. So we've gone through and we've calculated independent variability. So what independent variability is how far each of these individual data values are from the mean. The mean absolute deviation gives us one number that summarizes the variability from the mean. So instead of having, in this case, we have 25 different data values. So instead of having 25 different variability values, we have one number that tells us what the average variability is from the mean. So on your worksheet, you're going to see that you have a data table similar to this one. And these different columns are named for you. So the first one is data. Second one is the mean. Third one is the difference. So I'm going to walk you through this. And then the fourth one is the positive value. And then under positive value, we have the sum, which means we're just going to add them all up. The count, which is how many total data values we have. And then the mean absolute deviation. So I'm going to work over in Google Sheets because it's a little easier. So I'm going to be using this same data table. And I'm just going to copy it over to the data column. So 0 goes in the first one, 1 goes in the second one. Then we have 2 2s, 3, 4, 2 5s, and so forth. So over here in Google Sheets, you'll see that I've just put in all of our data values. So we have 25 data values, and we need to calculate the mean. So the way that we do that, we can use Sheets to help us do this. So I'm just going to highlight all of these. And this symbol over here, the function symbol, asks, what we can do or what we want it to do. So I want the sum. The sum means I just want it to add them all up. And that gives me a sum of 154. So that's just adding up these 25 numbers. Now I need to calculate the mean. So I'm going to do that in this cell. Anytime you want to do any type of calculation in Excel or Sheets, the first thing you have to do is click equals. In this case, I'm going to divide 154 by 25 because we have 25 data values. It gives me a mean of 6.16. So I'm going to fill that in, 6.16. And I'm going to copy that and paste it all the way down so I don't have to fill that in all the way, right? Okay, so the difference is I'm going to take 0 minus 6.16. So this is going to be negative 6.16. Right. Same thing here, 1 minus 6.16. So this is negative 5.16. 2 minus 6.16, so negative 4.16. Negative 4.16. Negative 3.16. Negative 2.16. Negative 1.16. And negative 1.16. I'm going to do this 6 minus 6.16 is negative 0.16. Seven minus 6.16 is 0.84. I'm just going to use Sheets to help me out so I don't have to do all the math work. because there are 25 different values. And this is a tool that you can use. I will share this spreadsheet with you. So as long as you pay attention and you're understanding how I'm doing this, then you'll be able to use this spreadsheet as well. Okay, so the third column, the difference column, this measures each individual variability, right? So we have this data value of 0. The average is 6.16. So that means that the 0 is off of the average by 6.16 values below it. This value of 1, again, the mean is 6.16. So this is off by negative 5.16. But when we're dealing with mean absolute deviation, we only want to know the positive value of the difference. So this is going to be positive all the way down. So I'm just taking the absolute value of all of these numbers. And again, absolute value measures a number's distance from 0 on a number line. And distance is always positive. So that's what the absolute value is. The absolute value, again, is just measuring a number's distance from 0, and distance is always positive. So if you travel from Madera to Fresno and then Fresno back to Madera in the same day, it's not like you traveled 0 total miles because you've gone there and come back. Distance measures time, so time never goes backwards. We haven't gotten to that point in our life yet. Be able to do that. Some high school football players would love to be able to do that. All right, so then in this row where it says sum, now we're just going to total up all of these positive values. So I'm going to highlight all of these, and I'm cheating because I'm using sheets. And it totaled them all up for me, 49.36. Count, again, is 25 because we have 25 total values. So the mean absolute deviation is just going to be 49.36 divided by 25, so equals this cell divided by this cell, which gives us 1.9744. Okay, so what this means is, in this case, this data table is measuring the age of 25 different cars, right? So the mean absolute deviation summarizes all of this variability. So that tells us, this tells us that the mean age, the average age of all of these cars is 6.16 years. And the difference, or the variability from that mean, is 1.97 years. So that could be positive 1.97 years more, or 1.97 years below 6.16 years. That's what the mean absolute deviation means. So given our entire data set of 25 different values, the average age of a car is 6.16 years, and the mean absolute deviation is 1.97 years, which means that given any car in that sample, the average age is going to be 6.16 years, or we can go 1.97 years above that, or 1.97 years below that. All right, hopefully this helps.